All right, my friends, let's get started. Sorry for the weird numbering, by the way. There were some victims of last-minute copy-paste there. It looks like people, for the most part, figured things out. Anyway, so for problem 3, with what I would call a full, system of equations like this with no gap terms, I would definitely have you do a process of elimination solution. So survey the x's, the y's, and the z's, knowing that whatever variable you choose to eliminate, you'll need to eliminate it twice, and you'll also need to use each of the 3 equations at some point. So with that said, I would recommend the z terms. I think that like a row 1, row 2 combo would make the z's eliminate, and then you could involve row 3 by doing row 3 and row 1. So I think that would be the path of least resistance. It's not the only way to do it. But here's what it would look like if you did it that way. So you could do row 1 plus row 2, and that would be pretty easy. So you'd have 3x plus 4y, and then 0z, and then 11 ones. And then you need to involve row 3, and so I would probably do row 1 and row 3. Because you don't really have to scale anything to get that perfect opposite setup that you're looking for. So we'd have 5x plus 2y equals 9, like that. There you go. Anyway, next I would recommend multiplying like equation 2 here by -2. So you could have like 4 and -4. So -2 times equation 2, what would that be? We would have 10x minus 4y equals -18. And then I'm going to add it to that first equation, that 3x plus 4y equals 11. Okay, we'd end up with -7x plus 0y equals -7, and that would mean that x would have to be +1. And now I can back substitute into one of these equations that has only 2 unknowns. I kind of like equation 1, but it doesn't really matter which one you pick, as long as it's one of these 2. So equation 1 would give me 3x, which would be 3 times 1, or 3, plus 4y equals 11. And then we could subtract the 3 over and divide by 4, and it looks like we'd end up with y equaling 2. So we've got x equals 1, y equals 2. Now let's take 1 and 2 and back substitute into one of the original 3 equations. I really like equation 2 for this, just because it's so simple. So that would tell us that x, or 1, plus y, plus 2, plus z has to equal 9, which means z would have to equal 6. There we go. Okay, final answer written in ordered triple form would have your x coordinate first, your y coordinate second, and your z coordinate third. There we go. Okay, now let's talk about scoring. So for points, move this so I can write. This could have gone down in a number of ways, but in your solution, you at some point would need to have an equation that just has 2 variables. It wouldn't have to be exactly this equation or in terms of x and y like mine, but basically what I'm looking for in your work somewhere is for you to have eliminated a variable. And that's 1 point and somewhere in your work to have eliminated a variable. Now the next thing I'm looking for you to have done is to have eliminated the same variable you eliminated here. So we eliminated z, we'd have to eliminate z again. So that's what we're looking for, is that you eliminated the same variable again. Okay, so 2 points so far. Next, you get 3 points for getting the correct x coordinates. So getting 1 for x, a point for getting 2 for y, and a point for getting 6 for z. The last point, my friends, is writing your answer as an ordered triple with x, y, and z in order. There we go, and that would be all 6 points. If you got perfect, you could just circle a 6. If you got some fraction of points, you could just write the number over 6 up here. It's probably the best place to put it if you used the printed test.